So we have two types of contractions or two types of twitches. One is an isometric twitch and one is an isotonic twitch. And an isometric twitch, I'll start describing this by talking about what the word literally translates to. Isometric, right? Same length. And in this scenario, we have a muscle that is not shortening, okay? And that name isometric should make you think about that, right? The muscle is not shortening. The muscle is not contracting. We're not moving or overcoming the load, okay? In an isotonic twitch, the tension is the same, isotonic or same tension. And in this type of twitch, we are overcoming the load. We are able to shorten the muscle. We are able to contract the muscle, okay? So just bear that in the back of your mind as we talk about these, but let's talk about some terminology before we actually get into describing these two twitches. So the contractile elements are the sarcomeres. I'll talk about contractile elements as I describe a twitch. And this is basically the sarcomeres. We've talked about the sarcomeres, these repeating units along the myofibril. These are the areas that are shortening, okay? These are the contractile areas of the muscle. These series elastic elements, these are the non-contractile parts of the muscle. And I kind of talked about this earlier, right? The tendons are non-contractile parts of muscle. They're simply attaching the muscle to the bone. What's really contracting is the muscle itself. The muscle belly or the muscle fibers, the fascicles, the sarcomeres, all of that's contracting. The tendon is just standing there as a point of attachment onto the bone. And so we can describe the contractile part as contractile elements and the tendons themselves as series elastic elements, right? Next, let's talk about what force is. And I kind of mentioned this a little bit earlier, but force exerted by a muscle that's contracting is what we call tension. And that is an ability to do work or lift or overcome a load, okay? And lastly, the force opposing the contraction is what we call the load. So if I'm trying to lift a bottle or something, this is the load, right? And my muscle has to generate some force to overcome this load. And in order to do so, it has to contract. And when it contracts, it's going to pull the tendon and the tendon will pull on the bone, which will help me to overcome that load. Okay, so let's understand the different moving parts. The muscle, which is the contractile part, the tendon, which is just doing the pulling, the load, which is opposing my force that I'm generating, and then my muscle is actually generating force by contracting. Okay, let's talk about this a little bit more. Let's use an example. Hopefully an example will make a little bit more sense. So we have an isometric twitch. This is where the load is greater than the tension. And that's because the tendons are moving, but the muscle does not. The tendons are moving, but the muscle does not. And a good example for this is if you're trying to lift something that's too heavy. I was watching a really cool Netflix documentary last night that talked about the strongest man alive, and he's able to lift 1,200 pounds. Which is a lot of weight. And he was trying to lift that load, and to other people, it felt like it was bolted to the ground, right? Their muscles were generating force, but they could not overcome that load. That's an isometric contraction, okay? Your muscle's generating force, yes, no doubt, but it's not contracting. It's doing nothing, okay? The load is too great to overcome, to be moved by that tension. And if you look at this example, the schematic example here, we have a piece of muscle that's suspended, it's relaxed, and we can sort of stimulate the muscle, right, which is stimulating or representing an action potential, such that the muscle should contract. Now, because the load that we're trying to lift is too heavy, we can stimulate this muscle all we want, right? It's not gonna shorten. And this is why we call it isometric. That length of the muscle will remain the same. The muscle never shortens. The load is simply too heavy. So we can stimulate this muscle, we can stimulate it, we can hit it with as many action potentials as we like. All it will do is contract, but never actually shorten, okay? And so we can see the tension going up here and then dropping off and no shortening happening. Let's look at an isotonic twitch. An isotonic twitch is where we have a tension that's greater than the load, okay? So we have enough force to overcome the load here. The load can be lifted. Again, think about you lifting something that you can actually lift, a book, a box, whatever. Your muscles actually shorten to help lifting that load, okay? And so we can see here that when we generate enough tension or enough force to overcome the load, this plateaus because we now have enough force, so the force remains the same, hence the term isotonic. Let's look at this schematic. We have, again, our lever here, our relaxed muscle suspended, the load being attached, and we see that the muscle actually shortens here simply because the load can be overcome by this tension. So the tension here is greater than the load. Okay, in this last little schematic here, we're comparing the two. So we can see a 5-gram load, which our muscle can shorten and lift. This is an isotonic contraction. We can see a 10-gram load, which our muscle can lift. This is another isotonic contraction. A 15-gram load, which again, our muscles can overcome. So the muscle shortens and we lift that load. So it's also isotonic. So all of these are isotonic. Now, if our muscle can only lift 17 grams and we try to lift a 20-gram load, we cannot overcome this load, right? And so this becomes an isometric contraction. Here, the load is greater than the force we can actually generate to lift the load. And so at 20 grams, we cannot physically lift a 20-gram load with muscles that can only generate 17 grams worth of force, okay? And hence we get an isometric contraction. Okay, and we can see the flattening off of these graphs, meaning that the tension is the same here, the tension is the same, the tension is the same, because it is able to overcome the load. Here, it just goes to maximum and drops off, okay, because we never actually overcame the load. We never generated 20 grams of force to overcome our 20-gram load, okay? Now, in actuality, in real life, we don't lift exclusively isotonic and isometric. In fact, we hardly ever see purely isotonic contractions. They're very rare. We always see an isotonic contraction that is preceded by an isometric contraction. I'll say that again. We rarely ever see an isotonic, a purely isotonic contraction. They are always preceded by isometric contractions. And what that means, right, in general terms, is before we can overcome a load, before we can lift something that's really heavy, there is a period where we're trying to lift it. Okay, let's say I'm lifting a heavy box. I'm gonna try to overcome that load, try to lift that box, and there's going to be a period at the beginning of that where I'm not actually overcoming the load. And so I'm gonna be contracting my muscles isometrically to start, and then when I do generate enough force to move the load, it switches to an isotonic contraction. Okay, so isometric contractions usually precede isotonic contractions. So you try to lift something, try to lift something, try to lift something, and then boom, you lift it. Okay, isometric, then isotonic. Okay, any questions